Keith Rucker here at VintageMachinery.org. Out at the museum today, and we got a little project going to be working on that I think you guys will enjoy, and it's going to be a gear repair job. And what I've got here, this is a cast iron gear. It's off of a Clausing, let's see, model 100 MK3 lathe. I believe this is what engages the back gears. This does not belong to me. This belongs to a viewer and gentleman that I actually sold a little Logan lathe to many years ago, and he's bought this Clausing now, was needing some help, and I offered to give him a little bit of help on fixing this gear. So there's two teeth on this gear that have been broken out. Don't know why, don't know what caused it, just was sent the gear. And after talking with Hector, the owner of this, going back and forth on some options on how we might try to repair it, the course that he really wants me to do is just to basically braze this area up and recut the teeth. So that's what we're going to do. You know, there's, I think, lots of ways that we could go about doing this. We could actually mill a little section out and put a piece of cast iron in there, and then cut it back out again. We could braze it up like we're suggesting. We could just get a blank of cast iron and make a whole new gear. You know, all those are valid options, but Hector indicated that he wanted me to just braze it up and go, and he's going to run it, and quite honestly, that should work fine, unless he gets the gear into a bind or something again, which is probably what broke it in the first place. So if he gets into something like that, broke a cast iron tooth, it'll probably break that braze out as well. But he's going to give it a try, and if that doesn't work, we can always make another gear, Hector. That'd be a fun project as well. So, course of action, how we're going to attack this. So first thing I'm going to do is I got just a block of steel here. We're going to make a mandrel to mount this gear on. This gear is going to have to get mounted in the lathe at some point during this process to get everything trued back up once we braze it up. It's also got to get mounted in the dividing head, and we need something to hold the gear. So first thing I'm going to do is I'm going to just take a block of steel here. We're going to make a mandrel to mount this on, have it turning true, and go from there. The next thing we'll do is we'll grind out the broken tooth area. We're going to braze that up, let it cool down, and then we'll put it back on the mandrel, go to the lathe. We'll return everything to the right diameters, the right width and diameter. And once that's done, we'll take it on the mandrel over to the horizontal milling machine where I've got it set up to do gear cutting, and we'll actually line this up so that the gear is indexed right, and then we'll use a dividing head to index to the different teeth and recut the teeth that we have filled in. So that's the course of action. Let's get at it. We're going to start by cleaning up this piece of metal. I'm just going to basically skin it off, get a good smooth surface on here, all the way down to somewhere in here. And there's going to be a flange here. The gear is going to actually come up from the back side up against that flange. And I'm going to turn down a step here. This will be the part that gets chucked up. And again, it'll go up to a little flange. It'll be larger diameter. So again, first thing, we're just going to true it up. Don't care what the diameter is on that. Just cleaned up. And then about 3 inches in, we'll cut a step and just whittle that down a little bit. Start by facing the end. Again, I'm just trying to clean this up. like the surface finish on that. We had a lot of rust on that outside, and it was just leaving a little bit rough surface. So I'm just going to take about 10 thousandths here and just put a clean cut on that. Come in about 3 inches. Again, this isn't got to be precise. That's about 3 inches. So that'll leave me a witness mark where I need to turn to, and we're going to turn this down. Everybody always asks me about speeds and feeds when I'm running the lathe, or any machine for that matter, and you know, I don't always mention it. I really don't even a lot of times pay attention to what it is. For me, it's just a matter of experience and feel and just what I'm comfortable with. But I will tell you, I've got the machine is running at 199 RPMs on the speed. The feed is, what was it, 9.4 thousandths per revolution. So every time it makes one revolution, it's feeding in 9.4 thousandths. And right now, I'm taking about a 50 thousandths cut to remove a total of 100 thousandths material. That's gotten pretty hot. I'm getting down to my final dimension. I'm gonna let that cool down. I'm shooting to make it 1 inch. It's really not that critical, but you know, I just want it to be right. So we're gonna let it cool down a little bit, and we'll make that final cut in a minute. While that's cooling down, I'm gonna go ahead and put a center in the end of this, just in case I decide I want to turn this between centers. I don't think I'm going to, but it's easy to do. I'm just going to do it right now. This is all cooled down now. I did change out cutters. This one just seems to give me a little bit better finish. Usually, we'll see what it does. So since we changed tools and it cooled down, I'm just gonna go in here. I got about 20 thousandths to take off. I'm just going here and touch off. And we're gonna take 8 or 10 thousandths or so just to get a good starting point to measure from again. got a couple of thousandths to fuzz off of here. And we're going to be really close. Should be good on my diameter, so I'm going to go ahead and come in here and just face off this backside while I'm in there. And finally, we're just going to come in here and break these corners. That should do. So what I've done is I've taken my chuck off, my regular chuck off, and put on this collet chuck, and I've got a 1-inch collet in here to fit that 1-inch diameter that we put on there. And the reason I did is a collet chuck is usually going to run with a lot less run out than a regular 3-jaw chuck. Yeah, I could put in a 4-jaw chuck and indicate it in, and but quite honestly, the collet chuck should get me there without having to go to that effort. So anyway, and haven't used it in a while, and just looked over there. It had the right collet in it. I said, hey, I'm just going to use that. So we're going to go ahead now and work on this side. So when we're running on the lathe, doing the lathe work, it's going to basically, this end that we got is going to be just like it is. It's going to be for just mounting it. Also on the dividing head, this end we're going to leave a flange here. The gear will butt up against that, so we'll turn it down to the diameter for the gear. There'll be a threaded section on here for a bolt to go on that will tighten that up against that flange, and whatever's left on the end is just to put a center in to give us some stability. So we're going to go ahead now and basically turn down to, I don't know, what do we want to leave there? Maybe 3/4 of an inch, probably ½ inch. I think that'll be plenty of a flange. And we'll turn that down to the diameter for the gear to fit on first. Just a mark for me to work off of. It's not a critical measurement, so we'll just cut up to that line. $350, so we got about another 100 thousandths to go. 460. I'm going to take 80 off, and we'll finish up from there. right, we got about 15 thousandths here, 14 thousandths left to go. We got some heat in the part, so I'm gonna cool it down. You know, just a little bit of word about when you're machining something to a tight tolerance. If you get a lot of heat in your part, remember that metal's going to expand, and your measurement will be different after it cools down. And we're usually machining for the part to be at a measurement at a, you know, a room temperature, an ambient temperature. So if it gets real hot and you're shooting for a right number, if you can hit it right on that mark, but then when it cools down, the part will shrink and you'll be out of tolerance. So that's the reason I'm cooling this down. Get another measurement on it now. And remember before it shrunk 1/1000th of an inch. So, you know, not a huge amount, but just cooling it down, it's 1/1000th of an inch smaller now than it was. So instead of 14 thousandths to go, we got 13. So I'm gonna change cutters out again. Again, I just get a little better finish with this other tool, particularly on light passes, which is what we're going to be making. So I'm going to come in here, we'll touch off, establish a 0 again that we can work off of. I'm just going to take about 8 thousandths here. When you're touching off, you know, you really don't have a good reference. You know, when you touch off, you can be off by a couple thousandths. So that's the reason I'm going to take a pass here, and then I'll get a good measurement, and my tool will be in the same place, and then I can work off of that for the final pass. If I hadn't changed tools out, and we hadn't cooled the part down, we could have just dialed it right in. We're just a couple thousandths over again. We'll go in there and get that last cut. So we're right on the measurement here, maybe just a 1/2 thousandths over. I've got my gear, and it's getting a little bit tight on there. I mean, it's going. I think what I'm going to do is just take some emery cloth and polish it a little bit to get a perfect fit. See how that fits. Yeah, I like that. That's a really, really nice fit. So I'm gonna go in here and face the back side of this, and we'll break those edges, and we'll be almost done. Check it one more time here. And I got that back shoulder on it. That looks good. I said we were almost done, but we're not. Still, what I want to do now is basically turn this end down a little bit more and thread it so that I can take a nut and tighten this up against that back flange. So I'm just going to take my Sharpie pen and mark that edge there. And we're going to turn this part down to 1 inch. And we're just basically going to take it just a little past that shoulder. at the edge. I want it because we're going to have where the thread will come up, and I just want to be just a little bit past that. About 8 more to go. Right on the money. Break this corner in here. So again, the gear will go on, we'll have a washer of some kind, and there'll be a 1-inch thread here, and I'm just going to turn this part down here on the end, probably about an inch in, just down to a smaller diameter. There's no reason for it to thread up all that way, so we'll probably go down to, we'll just cut it to 3/4 of an inch. These edges here. We're ready now to thread this. I've got my threading tool in here. I got my lathe set on 8 threads per inch. 1-inch 8 is what we're going to be doing. Got a mark over here. I want to leave a little shoulder for a washer to kind of go up in here, so I'm not going to thread all the way to it. And this will be close. I'm just going to give me a little witness mark in here. And that's where I'm going to try to disengage the thread tool, or to stop it. I'm going to start by just making a scratch pass and double check, make sure I got my thread pitch set right. Right on. So set this to 0. Come out, go back to 0. And let's get it threaded. let's give it a try and see how everything works. So the gear will go up on that first shoulder. I found a little, I don't know what that was, but it's going to work fine for a spacer in here. It doesn't fit it exactly, but it doesn't need to. Tighten that on there. All right, so that should give me something to hold my gear while I'm having to machine it again after I braze it up, as well as over on the dividing head. So the last step on this arbor or mandrel here is I need to cut a woodruff key in there. And I've already got this set up. I just shot a video a week or two ago showing how to set up for doing a woodruff key, so I'm not going to repeat that. If you want to go back and look at it, I'll put a link there for you. But we're just going to go ahead and put this in here. All right, that should do it. We'll try that out. So we got the keyway in there now. It matches the key here in the gear. This all goes together very nicely, and now that gear will not spin on that mandrel here. And this is ready. So we're ready to move on to the next step, which will be brazing this piece up so that we can go turn on the lathe and get ready to cut the gear teeth. So that'll be a wrap on this video. As always, thank you guys for watching. If you haven't already, please subscribe to the channel, and we'll be back soon with the conclusion of fixing this gear. Thanks for watching.